Hello everybody, this is the fourth video in the series Mode Shapes. In the previous video, we discussed about altering the structural properties of the plate, as in changing the material of the plate and studying the effect it has on natural frequency and mode shapes. In this video, we're still altering another structural property, which is the thickness of the plate, and it's going to study the effect it has on natural frequencies and mode shapes. So this is the plate, the thicker plate that we're intending to study. So the dimensions of the plate are still the same, it's 100 by 100, but the only difference is we're increasing the thickness. In fact, we're doubling the thickness from 2 mm to 4 mm. While the other parameters are still the same, we're using the same material, steel, with the same material properties, and also we're constraining the plate along the perimeter as we have done so far. So the plate is constrained along the perimeter. This parameter doesn't change this unless we're altering the boundary conditions, which we're not. So as long as the boundary condition is the same, the number of constrained and unconstrained nodes are still the same, and the total degrees of freedom of the plate doesn't change. So we perform the analyses and we get the natural frequencies. I have chosen first 8 modes, so I get the natural frequencies for the first 8 modes. So let's have a look at the mode shapes. So this is the first mode of the plate. We're talking about the 4 mm thick plate, which is 3498 Hertz. This is the second mode at 7067 Hertz. This is the third mode, again at 7067 Hertz. This is the fourth mode at 10,014 Hertz. This is the fifth mode at 12603 Hertz. This is the sixth mode at 12693 Hertz. This is the seventh mode at 14946 Hertz. And finally the eighth mode again at 1496 Hertz. So now let's compare the frequencies, natural frequencies of the 2 mm thick plate and the 4 mm thick plate. Now, as you can see here, we have changed the structural properties, which means we have, increased the thickness of the plate, and we should expect a change in the natural frequency, which we are. Now, another important thing here we can note is like we have, increased it, sort of double the thickness of the plate, and for some reason the natural frequency is also almost doubled, as you can observe here. So we know that the natural frequencies have changed. Now let's see if the mode shapes have remained the same or they have changed as well. So this is the first mode. On the left you can see the mode shapes of the 2 mm thick plate. On the right you see the mode shapes of the 4 mm thick plate. The material is still the same. So in this case we observe that the mode shape is the same, except that the amplitudes are different. This is the second mode shape. There's the same, except the amplitude. The third mode shape, the same. The fourth mode shape, still the same. The fifth mode, same. Sixth mode shape, still the same. Seventh mode, maybe a little different. And the eighth mode, a little different. Alright, to conclude, what we have done here in this study was just alter the thickness of the plate while keeping all the other parameters the same. We only increased the thickness from 2 mm to 4 mm, or double the thickness of the plate. So indeed we have altered the structural property, and as a consequence the natural frequencies did change. In fact, it was also doubled, and the mode shapes have stayed the same, but in some cases they have changed. Alright, thank you for watching this video. I hope you enjoyed it. Have a great day.